Hello friends, in this video we will look at the queue data structure. First thing that we have to understand about the queue is that whatever data you put, it is first in, first out. That means whatever data you will put into the queue, if you will put A first, then A will come out first as output. I will take one example. If I take a string dear and I put this is 0 1 2 3 4, I put D at the first position, then E, then A, and then R. Then when I will, this will become the rear side of the queue, that is the back side from where the insertions will be made, and this will become the front side of the queue where the deletions will be made. So now if you will read, come and want the data out, then first D will come out, then E will come out, then A, and then R. So dear will maintain its relative order of the individual characters. So input is from here and output is from the other end. So that is why a queue is a FIFO data structure. Hello friends, in this video we will look at the queue algorithms, that is to insert, which is known as enqueue, and to delete, which is known as dequeue. So in the previous video we have discussed that if we enter the word dear into the queue, then the output will be DEAR only. That means the relative order of the words will be maintained, which is unlike stack, and this is the FIFO property of the queue. Now we will come to the algorithms of the queue. So suppose I have an array, and in this I have 0, 1, 2 and 3. That means size of the array is 4. So there are 4 slots in the array. So the size of the queue is 4. And now I will maintain two variables. Front is the point from where the deletions will be made, and rear is the point where the insertions will be made, and initially both of them are -1, indicating that the queue is empty. Now what I will do, suppose I have the operation enqueue 5, enqueue 7, enqueue 9, then dequeue, then enqueue 10. Suppose these operations have to be performed. So first of all, what I will do, for enqueue 5, I will go to the rear. I will increment the rear by 1, and what I will do at point 0, I will go and write the value of 5. So this is the insertion, and rear is pointing on this number. Now what happens, I will check if the front is -1. Now since the deletion will be made at the front, if we leave the value of front to be -1, when the dequeue function will run, it will check if front is -1, then there is an underflow, that means the queue is empty. So we need to change this. So what we will do, whenever the first insertion is made into the queue, after every insertion we will check if front is equal to -1, then it should be updated to 0. So now front is also pointing towards this point, and rear is also pointing towards this point. So if a dequeue will come, I will dequeue from the front, and if a insertion will come, I will increment the rear and place the new value. For example, now we have enqueue 7. So what I will do, I will increment the rear by 1. It will become 1. So at the first position, I will put the value of 7. Then front is here, but rear has shifted on this number. So front is still pointing towards 5. Now there is a enqueue 9. So again I will increment the value of the rear by 1. So it will become 2, and I will place the value of 9 here. Now rear is pointing towards this point. Now a dequeue request will come. When dequeue comes, first of all I will check if front is 0 or -1. If front is -1, that means there are no elements in the queue, but front is not -1, front is 0. So what we will do, we will read the value from the queue, and we will increment the front by 1, because now the next element that we can dequeue is 7. So therefore front will be incremented by 1, and rear is pointing towards 9, front is pointing towards 7. Now next the enqueue will come. Again what we will do, we will increment the rear by 1. It will become 3, and at third position I will put the value of 10. Now what happens is the rear will point here towards 10 and front is pointing towards 7. This value has already been read. Front is at 7. At this position we have front, and at this position we have the rear. This is the updated status, and this 0 position is empty. Now if a enqueue request will come, what will happen? Rear will try to become 4, which is the size of the array, which is not allowed. That index is not valid index, and therefore a overflow condition will hit. And we can dequeue all the 3 values, and then again the queue will start from the beginning. Now there is a problem with this, because this space is vacant. Still I am getting a error of overflow, which is not right thing to happen, and therefore this queue arrangement is known as a linear queue, in which the queue grows in a single direction. In the next video I'll be discussing the circular queue, in which the queue will work in a circular fashion. So let us now look at the algorithms of the enqueue and dequeue. So now looking at the algorithm of enqueue, enqueue will receive the data to be inserted in the queue as input, and what we have to check, first of all we will check for the overflow. This is the first step. Then second step is to increment the rear, and the last step is to place the value. And then one step that I have discussed, check front. What is the value of the front after insertion? We have to check it. So for overflow, what is the condition? If rear plus 1 is equal to the size of the queue, it is a overflow. So we will print this message and return. Otherwise what we will do, rear plus plus, and then place the value means queue is a array, so queue with the subscript of rear is equal to the data the user has passed, and then we will check if front is equal to minus 1, then what we will do, we will update the front to 0. So this is the algorithm for the enqueue. First you check for the overflow, then you increment the rear, then you place the value and check the front for being minus 1. Then for the deletion, we have the dequeue algorithm, and in this we will check for the underflow, then we will read the value from the queue, and then we will here also increment will happen, increment the front. So what we will check here, underflow the condition is if front is equal to minus 1, it is a underflow, so we will print this message. Then read the value. So what we will do, we will, in a temporary variable val, we will read the value of q at front, and then now I have to increment the front. So before incrementing the front, I have to check, was this the last element that I have deleted from the queue? So for that the condition will be, after reading the value, if front is equal to rear, then this was the last element that I have removed from the queue. And so what I will do, I will set the front is equal to rear is equal to minus 1. Otherwise I will say front plus plus. So what is the condition? If the front is equal to rear, that means that the rear and front both have, the queue has become empty, and therefore they should be reset to minus 1. Otherwise the front is equal to front plus plus. Let us discuss this case once again. So what we have is, I have a queue, I make a enqueue operation, enqueue 5, and then I will make a dequeue operation. This is 0, 1, 2, 3. Size of the queue is 4. The rear is minus 1 initially, and the front is also minus 1. Now when I make a insertion enqueue, I will increment the rear. It will become 0. I will place the value here. Rear is pointing at this position. So first I checked for the overflow. Rear plus 1 is equal to the size. No, it is not. So we will place the value at this position. And then we will check if front is equal to minus 1. Yes, it is. So what I will do, I will update the front to 0. Now both front and rear are pointing towards 5. Now when a dequeue request will come, I will check, is front equal to minus 1 underflow? No, it is not an underflow. So what we will do, we will read this value from the front. Now I will check if front is equal to rear. Yes, it is. That means this was the last element that I have read from the queue, and both the front and rear should be reset to minus 1. So if there is a single element in the queue and we are performing a dequeue operation, we need to reset the queue to minus 1 so that the queue can begin insertions from the starting, and the underflow condition will be met when we will come to read from the queue. I hope this video is helpful to you. In the next video, as we have discussed, that after the rear reaches this point and still there is space at the 0, this space is not utilized by the linear queue, which is this data structure that I have discussed. In circular queue, this will be overcome, and how it is overcome I will be discussing in the next video. Thank you very much for watching.